Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acetic anhydride is a reactive acylating agent that undergoes nucleophilic acyl substitution reactions with nucleophiles such as amines, alcohols, and aromatic rings via Friedel-Crafts acylation. The key is to assess whether each reagent can act as a nucleophile or catalyst to react with acetic anhydride. Moving on to the next step. Dimethylamine, HN, CH3, is a good nucleophile, secondary amine. It reacts with acetic anhydride to give N-dimethylacetamide plus acetic acid, which then protonates another molecule of amine to give CH3CO2 and H2N plus CH3, This reaction is well known and feasible. Not the answer. Moving on to the next step. Ethanol, CH3CH2O, is a nucleophile, oxygen nucleophile. It reacts with acetic anhydride to give ethyl acetate, CH3COOH to CH3, and acetic acid, CH3CO2H. This is a standard esterification reaction with acetic anhydride. Feasible. Not the answer. And for the final step. Benzene with UlCl3, Lewis acid catalyst, undergoes Friedel-Crafts acylation with acetic anhydride to give acetophenone, CH3COC6H5, and acetic acid, CH3CO2H. This is a well-documented reaction. Feasible. Not the answer. NaCl is proposed to react with acetic anhydride to give acetyl chloride, CH3COCl, and sodium acetate, CH3CO2 Na+. This reaction is not feasible because Cl from NaCl is a very poor nucleophile in this context, and more importantly, the thermodynamics are unfavorable. Acetic anhydride is less reactive than acetyl chloride. The reverse reaction, acetyl chloride reacting with acetate to form acetic anhydride, is what can occur. The equilibrium strongly disfavors formation of acetyl chloride from acetic anhydride and NaCl. NaCl does not have the nucleophilicity or driving force to convert acetic anhydride into acetyl chloride under normal conditions. Why other options fail as the answer? Options A, B, and C all involve genuine nucleophiles or activated conditions, Lewis acid catalyst, that make the reaction with acetic anhydride proceed readily. Option D involves NaCl, an ionic salt whose Cl ion cannot displace the acetate-leaving group from acetic anhydride under normal conditions because the reaction is thermodynamically unfavorable. Therefore, the correct answer is D. Therefore, the correct answer is option D.